Why does your brain suddenly go from 0 to, like, warp speed after that first sip of coffee?
Right.
For millions of us, that morning brew isn't just a habit. It's the activation sequence.
Yeah.
That moment you go from, sleepy bystander to, well, maybe not superhero, but at least a functioning human being.
It really is a chemical power-up
Right.
in a way. But the common idea that caffeine gives you energy is actually, well, it's pretty misleading.
It's leading how?
What we discovered digging through this stack of literature you sent over, it shows a level of complexity that's really customized. It depends on your unique genetics, even the exact timing of when you drink it.
Okay, that's fascinating. So our mission today, everyone, is to really cut through the noise. We're doing a deep dive into the actual science of why coffee makes you feel alert,
Mm-hmm.
and also the incredible history of how this, well, magical bean went from an Ethiopian curiosity to this global powerhouse,
Yeah.
second only to oil and trade value. That's wild.
It is wild. And we have the data now to tell you not just how it works, but maybe even when you should drink it for the best effect.
All right, let's get into it. You said gives you energy is misleading.
Yeah, what's really fascinating here is that caffeine doesn't actually add energy to your system. It's more like, well, it's masterful molecular espionage.
Espionage. Okay, intriguing.
It just removes this natural brake, a brake your body is constantly applying to your brain's arousal systems, and it builds up the longer you're awake.
Okay, let's unpack that.
Yeah.
We've all felt that. That mounting sleep pressure by the end of the day, right?
Yeah.
That pull towards the couch. What chemical is that? What's building up?
That's adenosine. It's an endogenous neurotransmitter, basically, a natural signaling chemical your body makes.
Right.
And it accumulates as a byproduct of your brain cells just doing their job, firing away all day. The longer you're awake, the more adenosine builds up.
And that's the sleep pressure people talk about.
Exactly. Researchers call it the homeostatic sleep drive. It signals fatigue by binding to these specific spots, these receptors in your brain, mainly the ARO and AO types.
A and AA. Got it.
When adenosine docks there, it basically hits the off switch on alertness. It promotes sleep, suppresses arousal. It's your body saying, okay, time to wind down.
So adenosine is the Sandman chemical, kind of slowly putting you to sleep. How does coffee stop that? How does it block the Sandman?
Caffeine is what we call a competitive antagonist. It sounds technical, but the key is its shape.
Okay.
It's so structurally similar to adenosine, it looks almost identical at the molecular level, so it acts like a chemical imposter.
A disguise.
Precisely. It slides right into those same ARO and ARO receptor parking spots that adenosine wants. But here's the crucial part. It binds without activating them.
So it takes the spot, but doesn't push the button.
Exactly. It just sits there, like a car parked in a reserve spot, blocking the real adenosine from getting in and applying that natural chemical brake.
So it's like putting tape over the doorbell. The signal can't get through.
That's a really good analogy, actually. And research, some really cool studies using genetically modified mice showed this blockade is very targeted.
To those specific receptors.
Yes, they figured out the wake-promoting effects are primarily coming through those AERO receptors, especially the ones located in a specific brain area, the shell of the nucleus accumbens.
Nucleus accumbens, that rings a bell. Isn't that linked to motivation and reward?
That's the one. And get this. When they deleted those specific AEE receptors in the mice, caffeine just didn't work anymore, didn't make them more awake.
Wow. So it's really that specific pathway.
It seems to be the main one for wakefulness, yeah. Other stimulants, like modafinil, still worked in those mice, but not caffeine.
Okay, this is where it gets really interesting for me. Because caffeine doesn't just stop at blocking the off switch, right? It seems to kick other systems into gear, too. It's not just stopping sleepiness. It's promoting alertness actively.
Absolutely. It's a system regulator. It doesn't stop there. It notably modulates or sort of influences dopamine activity.
Dopamine, the feel-good molecule.
Right. Now, caffeine doesn't directly bind to dopamine receptors itself. Instead, it influences these complex structures called receptor complexes. Think ANERO and AAA heteromers.
Whoa, okay, slow down. Heteromers. What does that mean for, me drinking my morning cup?
Haha, fair enough. Think of these receptors like chemical dance partners. Adenosine receptors and dopamine receptors often pair up on the surface of brain cells.
Okay, dance partners. I can picture that.
When caffeine blocks the adenosine partner, it changes the way the dopamine partner can interact or become available.
So blocking one affects the other one's availability to dance.
Basically, yes. And we have evidence from brain imaging studies like positron emission tomography or PE scans. They've shown caffeine actually increases the availability of dopamine receptors in a part of the brain called the striatum.
So more docking spots for dopamine become available.
Exactly. In simple terms, it means you have more access to the neurotransmitter linked to reward, focus, motivation. And those changes they see in the ventral striatum, they correlate directly with how alert and focused people say they feel.
Okay, that explains so much why the boost feels kind of motivational. It's not just being awake, it's feeling like you want to do things like, let's tackle this inbox.
That motivational piece is definitely compounded by another effect. The release of norepinephrine, also known as noradrenaline, and other related chemicals called catecholamines.
Okay, what do those do?
These activate your sympathetic nervous system. That's your body's emergency power switch, the fight or flight response system.
Right, the adrenaline rush feeling.
Pretty much. That causes the increased heart rate, maybe slightly higher blood pressure, definitely increased vigilance, and just general arousal. Your system is on high alert.
And there's more.
We also see some involvement of serotonergic pathways. Serotonin systems also play a role in arousal, keeping vigilance up, and reducing fatigue. It all adds up to this robust, sustained effect.
It's like a whole cascade of effects, starting from just blocking that one molecule, adenosine.
It really is a cascade.
So, okay, we know the main player is caffeine. But coffee isn't just caffeine and water, right? It's famously complex. Thousands of compounds. Is anything else in that cup doing some of the heavy lifting, helping out?
Yes, absolutely. Coffee is truly a complex brew. It contains a supporting cast of related molecules, other methylxanthines.
Methyl-xanthines.
Like caffeine. Exactly. Caffeine is the most famous methylxanthine, but coffee also has smaller amounts of theobromine. That's the stimulant more famous in chocolate, and theophylline. Theophylline is actually used sometimes as a medicine for respiratory conditions. It's also a CNS stimulant.
Okay, so cousins of caffeine.
Right. But the real star player, often completely overlooked, is a compound called paraxanthine.
Paraxanthine. I've definitely never heard of that one. Sounds like a superhero name. What makes it a hidden power-up?
Haha, maybe it should be. Paraxanthine is the primary metabolite of caffeine in humans.
Metabolite, meaning what your body breaks caffeine down into.
Precisely. Your liver converts most of the caffeine you drink into paraxanthine. And here's the kicker, the wow effect you were looking for. Paraxanthine itself has significant psychoactive properties. It keeps you alert, too.
No way. So it's not just the caffeine, it's what the caffeine becomes.
Yes, and because it's cleared from your body more slowly than caffeine, its levels in your blood plasma often end up exceeding the levels of the original caffeine itself.
So it hangs around longer.
Much longer. And this likely explains why the feeling of alertness from coffee can last for hours. It might be the paraxanthine sustaining that cognitive edge long after the initial caffeine buzz has peaked.
Mind blown. So that feeling of sustained focus, hours later, that might be mostly paraxanthine doing the work, not the caffeine I drank originally. That's serious chemical teamwork.
It really highlights the complexity. And we can't forget the other stuff, too, the non-stimulant compounds.
Right, like antioxidants. People talk about those.
Exactly. An average cup of coffee gives you roughly 200 milligrams of things called chlorogenic acids, or CGAs, and other polyphenols.
CGAs.
Now, these aren't stimulants like caffeine or paraxanthine, but they show biological activity. They seem to protect your neural tissues, your brain cells, from oxidative stress and inflammation.
So they're like maintenance workers for the brain,
Yeah.
cleaning up the stress.
That's a great way to think about it. They help maintain optimal brain function, especially maybe when you're tired or stressed. This might indirectly enhance those cognitive benefits we feel from the caffeine and paraxanthine, that keeping the machinery running smoothly.
Okay, this whole picture is way more intricate than I thought. Which brings us perfectly to the personalized strategy part. We've got the chemistry down, but we all know the practical effect is wildly different from person to person.
Oh, yeah.
I mean, I can drink 3 cups and maybe feel a little buzzed, but my friend has 1 sip of espresso and they're practically vibrating off the walls. What's going on there? Is it genetics?
That's exactly where genetics comes in. This is where we see the real personalization of the coffee strategy. It often boils down to tiny variations in your DNA called genetic polymorphisms.
Polymorphisms. Okay. Little tweaks in the code.
Right. And the most studied one, the one with the biggest impact on caffeine, involves a gene called CYP1A2.
CYP1A2. Rolls right off the tongue.
Uh-huh. Yeah. This gene provides the instructions for making the main enzyme, the main protein, that breaks down and clears most of the caffeine from your system.
Ah, so your DNA basically dictates your caffeine cleanup speed, like how fast your liver processes it.
Precisely. Based on which version of the CYP1A2 gene you have, you're generally categorized as either a fast metabolizer or a slow metabolizer.
Fast versus slow. Okay, what's the difference in experience?
While people with the fast version, typically the AA genotype, clear caffeine about 1.6 times faster. And interestingly, some studies suggest they might actually experience enhanced cognitive benefits from coffee.
Really? Better focus if you clear it faster.
It seems that way sometimes. Now, the slow metabolizers, often with the CC genotype, they have caffeine hanging around in their system for much longer.
Which sounds good maybe, but
But it can lead to prolonged effects, sometimes unwanted ones like anxiety, jitters, or sleep disruption, especially if they drink a lot. That friend vibrating off one espresso, they might very well be a slow metabolizer.
okay, so their body is just overwhelmed because the stimulant is overstaying its welcome. That makes sense.
Exactly. And it's not just CYP1A2. There are other genes involved too, like one called COMT.
COMT, what does that do?
COMT affects how you break down stress hormones, like adrenaline.
Mm.
If you have a variant that makes your COMT enzyme less active, you might naturally have slightly higher levels of these stress chemicals.
So you're already a bit more wired.
Potentially, yes. And those people tend to be much more sensitive to caffeine's side effects, the jitteriness, the anxiety. It pushes them over the edge more easily.
Fascinating. So my personal reaction is really a cocktail of my genes. Now, if we connect this genetics piece to the bigger picture of timing, knowing we all process it differently, is there a scientifically proven sweet spot, a best time to drink coffee?
There is, and it's about working with your body's natural rhythms, not against them. The key is strategically avoiding a collision with your body's own built-in alertness system, the cortisol awakening response, or CRR.
Cortisol, the stress hormone that wakes us up.
Yes, cortisol gets a bad rap sometimes, but it plays a vital role in our natural sleep-wake cycle. It naturally peaks in the morning, usually sometime between maybe 7 and 8 a.m. for most people, helping you wake up and feel alert.
Okay, so my body is already giving me a natural wake-up call then.
Exactly. And if you drink coffee right during that peak cortisol window, you're essentially just stacking caffeine stimulation on top of an already high level of natural alertness.
Which sounds redundant, like
Sure.
putting rocket fuel in an already speeding car.
It kind of is, and it can lead to overstimulation, that jittery feeling. It might reduce the effectiveness of the caffeine later and potentially even speed up tolerance development, meaning you need more coffee to get the same effect over time.
So what's the optimal strategy then? When should I drink it?
The research suggests the optimal timing is about 90 minutes after you wake up.
90 minutes, an hour and a half. Oof, that sounds challenging if I wake up feeling like a zombie at 6 a.m.
Haha, I hear you. But the idea is to let your natural cortisol peak happen, let it start to gently decline, and then introduce the caffeine.
Why then?
Because then the caffeine isn't competing with your cortisol, it's amplifying your alertness mechanisms as the natural boost starts to fade. It provides a smoother, more sustained lift, rather than that jarring jolt followed by a potential crash later.
Okay, 90 minutes post-waking. Wait for the natural wave, then ride the caffeine wave. I can try that. Maybe.
It's about leveraging your biology instead of fighting it. But speaking of timing, we absolutely have to talk about the downside risk, drinking it too late.
Yes, the dreaded coffee-induced insomnia.
It's very real. Studies have shown that evening caffeine, even just the amount in a double espresso taken just 3 hours before your normal bedtime, can significantly delay your body's internal clock.
How significant?
It can push back your natural melatonin rhythm by approximately 40 minutes.
40 minutes.
Yeah.
From one drink 3 hours before bed. That's a huge shift in your master circadian clock.
It is a potent effect, yeah. It really highlights caffeine's powerful influence, acting deep within your cellular timing mechanisms, likely through pathways involving something called MMP.
Okay, noted. No double espressos after dinner if I want to sleep. Now, this brings up maybe the most crucial trade-off, especially for us regular habitual coffee drinkers. If you rely on coffee every single morning, are you truly getting a boost in performance, or are you just getting back to zero, just staving off the withdrawal?
That is the million-dollar question, isn't it? Am I Captain America getting the super soldier serum, or am I just, Bucky Barnes before he gets his memory back, just trying to function?
Exactly. Am I enhancing myself or just treating a self-inflicted handicap?
The literature suggests the answer is, well, it's nuanced. It's probably a bit of both.
How so?
There's strong evidence suggesting that for people who drink coffee every day, A significant portion of the apparent performance benefits. That feeling of waking up, clearing the fog is often withdrawal reversal.
Withdrawal reversal, meaning I just feel bad because I haven't had coffee yet.
Pretty much. You're simply restoring your baseline cognitive performance, which was actually suppressed because your body has adapted to the regular presence of caffeine and is now experiencing mild dependence.
Ouch. So the headache, the fatigue, the bad mood if I don't have it, those are real withdrawal symptoms.
Absolutely. They're well documented. They typically peak around 24 to 51 hours after your last dose and can take anywhere from 2 to maybe 9 days to fully resolve if you quit cold turkey.
So I might just be paying this daily caffeine subscription fee mainly to prevent the unpleasantness that the subscription itself created. That's slightly depressing.
It can feel that way. However, it's not just withdrawal reversal. That's important to state.
Okay, good. There's hope.
Yes. Coffee does produce genuine, measurable improvements in cognitive function. Things like attention, focus, executive function, your planning and decision-making skills, and working memory. These effects are real.
Especially when tired.
Especially when you're sleep-deprived, yes. That's when the benefits really shine. Moderate doses, generally somewhere between maybe 40 and 180 milligrams, seem to be the sweet spot. Some research suggests these doses help reorganize brain functional connectivity, making your brain networks operate more efficiently.
So the true boost is real, but for habitual users, it's often layered on top of this foundation of dependence and withdrawal avoidance.
That seems to be the most accurate picture, yeah.
Okay, let's pivot now. We've gone deep on the neurochemistry, the genetics, the timing. Let's place this amazing bean in human history. Because this isn't just a science story, is it? It's a global culture story. You mentioned it fueled the Enlightenment.
It really did play a fascinating role. The story, as best we know, begins way back on the high plateaus of Ethiopia.
Right, the legend of Kaldi, the goat herder.
That's the popular one, yeah. Probably a bit romanticized, the story from the 9th century about him noticing his goats getting super energetic after eating these red coffee cherries.
Fun story, though.
It is. But historical evidence suggests the indigenous Oromo people in that region were likely already chewing the coffee berries or maybe mixing them with fat for energy and stamina long before that, probably for sustenance on long journeys.
Ah, so the idea of it being an energy booster, a performance enhancer, is baked right into its origins. How did it get from Ethiopia to, well, everywhere?
The key players were Arab traders. They cultivated coffee more systematically, probably starting in Yemen. And by the 15th century, they had really popularized the whole culture around it, roasting the beans, brewing the drink, and importantly, establishing public coffee houses.
The Kovekane.
Exactly. In big centers like Cairo, Mecca, Damascus. These weren't just places to grab a quick drink like today. They became incredibly important social and intellectual hubs.
You mentioned earlier they were called schools of the wise. That's such a great name. And it links back perfectly to the brain science we talked about, right?
It really does. If coffee is making people more alert, more focused, maybe even enhancing dopamine-related motivation, it naturally fuels conversation, debate, intellectual curiosity.
Right, yeah.
The coffee house provided this perfect environment for that enhanced brain state. People were gathering, alert and focused, sharing news, discussing politics, philosophy, business, often late into the evening, which was unusual then.
A public space, but not centered around alcohol. That must have been huge.
It was revolutionary. This intellectual ferment, arguably fueled by caffeine, was crucial as coffee spread into Europe in the 16th and 17th centuries. It became a vital ingredient in the social fabric of the Age of Reason, the Enlightenment. Lloyd's of London started in a coffee house.
Wow. So coffee literally helped wake up the world, intellectually speaking.
In many ways, yes. From there, of course, demand exploded, and it rapidly grew into this massive global commodity. And that's where we also see the darker side of its history.
Yeah, you mentioned trade.
Its expansion, especially into the Americas and the Caribbean, became deeply entangled with European colonial economies. Vast plantations were established, often relying heavily and tragically on enslaved labor from Africa to meet the insatiable demand back in Europe.
So the history is complex, fueling intellectual progress on one hand, tied to exploitation on the other.
Very complex. It fundamentally shaped modern global trade relationships between the producing countries, often in the global south, and the consuming nations.
This whole deep dive has been absolutely illuminating. It shows just how much is packed into that simple cup: chemistry, genetics, history, culture. Let's try and boil it down. What are the 3 core takeaways for everyone listening?
Okay, three key things. First, remember coffee's main trick is that chemical espionage. It worked by blocking the sleep pressure molecule adenosine from doing its job,
Right.
especially at those key receptors in your brain. It's like removing the brake on alertness, not adding fuel.
Okay, takeaway 1. Block the brake. Got it. What's number 2?
Number two, personalize your strategy. Your experience is heavily shaped by your genetics, particularly that CYP1A2 gene, determining if you're a fast or slow metabolizer,
Uh-huh.
and also by timing relative to your body's natural cortisol rhythm. For the potentially best effect, aim for that sweet spot about 90 minutes after waking up.
Takeaway 2. Know your genes. Watch the clock. Aim for 90 minutes post-wake up. Okay? And number 3.
And third, remember coffee is a team effort chemically. The sustained feeling of alertness isn't just caffeine, it's a synergy, especially involving that powerful metabolite paraxanthine, which hangs around longer.
Right. The hidden power-up.
Exactly. And that works alongside those other beneficial compounds like
Okay.
the neuroprotective chlorogenic acids, the CGAs. It's the whole cocktail.
Takeaway 3. It's a chemical team, led by caffeine, but supported by paraxanthine and CGAs. Excellent summary.
Thanks.
You know, this research really empowers us, doesn't it? We can shift our relationship with coffee from just this reflexive, habitual thing we do to a much more optimized, intentional strategy. By understanding our own biology, our genes, our circadian rhythms, we can potentially maximize the cognitive benefits while minimizing the downsides like dependence or sleep disruption.
It really does put you more in the driver's seat, allows you to leverage your biology intelligently.
It does. So here's a final thought for everyone to chew on, maybe over your next cup whenever you decide to drink it.
Uh-oh.
If a good chunk of the daily benefit we feel from coffee, especially as regular drinkers, is actually just reversing those mild withdrawal symptoms, is that morning cup truly making us smarter, sharper, better? Or is it mostly just the necessary cost of admission to feel normal in the life we've built around being a regular coffee drinker?
Oh, that's a deep one to end on.
Something to mull over. Maybe wait until that 90-minute mark hits before you tackle it.